I don't know what just happened there. If you had a question, Max, go ahead and ask it again. In the meantime, I'll continue. All right. So we now add the two half reactions back together. What the hell just happened? I don't know. Hopefully people will find their way back in here. All right. So anything that appears on both sides of the reaction are going to cancel out. Okay, good. No questions. Anything that appears on both sides will cancel out. So, the only thing that will definitely cancel out perfectly, absolutely, for definite, is going to be your electrons. Because, it's designed that way. So 10 electrons on the left, 10 electrons on the right, they cancel out, they disappear. Your hydrogen and your water will probably cancel out, but not perfectly. Okay. So for example, here we have 8 H2O up here. We don't have any H2O down here to cancel out with. But we do have both hydrogen on the right and on the left. So those will cancel out. But not perfectly, because we have 10 hydrogen down here, we have 16 up there. So the 10 hydrogen will be canceled out completely, and then 16 minus 10 leaves us with 6. So that's all the stuff that can cancel out in this particular reaction. So now we just add them together. All the reactants, all the products. All right. So just all of our reactants on one side come down to become the reactants. All the products on the other side come down to become our products. So that is where we would stop and start double checking if this were a reaction performed in acid. But if you go back and look, you'll see I said base. Okay, so always double check the problem, see if you're doing this in acid or in base. Okay, so in this case, we're doing it in base, which means we are going to have to get rid of the H+. So once again, I need some room. All right. So you get rid of the H+ using OH-. We have 6 H+ on the left, so we'll need to cancel that out with 6 OH-, 6 hydroxides. But whatever you do to one side of the reaction at this point, you have to do to the other to keep it balanced. So we add 6 hydroxide to the other side as well. H+ plus OH-, acid plus base neutralizes to make H2O. Which means we once again cancel out. Okay. We have 6 water on the left, we have 8 water on the right. So they're going to cancel, leaving us with just 2 water on the right. So once again, we write it out for a little bit of clarity. And there is the balanced reaction in base. Now, I am absolutely certain that I did this correctly, no mistakes, but it's always possible to make mistakes because this is a long, complicated process. So let's go ahead and just, double check everything to be sure. So first up, we're going to double check the matter. Just see that the atoms are all balanced. So, manganese, oxygen, and hydrogen. So 2 times 1 gives us 2 manganese on the left. 2 times 1 gives us 2 manganese on the right. Oxygen. 2 times 4 is 8. 5 times 2 is 10, meaning we have 18 oxygen on the left. 5 times 2, 2 times 1, 6 times 1 gives us 18 oxygen on the right. And for hydrogen, 5 times 2 is 10. Hydrogen 2 times 4, 6 times 1, we have 10. All right, so that means that all of our atoms balance out. Let's check charge. So very often in chemistry and physics, charge is represented with a lowercase q. It's not the only time, but it's one of the times. All right. So on the left we have 2 times -1 makes -2. 5 times 0 is 0, meaning we have a total of -2 on the left. 2 times +2 is +4. 0, 0, and -6 means a total of -2 on the right. So charge is balanced as well. Huzzah! And then the only thing left to check is the coefficients. Namely, can they all be divided by some number? Now, are they all even? Divide by 2. Can they all be divided by 3? Divide by 3, and so on. 2, 5, 2, 5, 2, 6. No, there's no common denominator. Okay, great. So that checked out as well. So this is the balanced reaction in base between permanganate and hydrogen peroxide. That is a lot of work. Takes a long time. Takes longer when you're explaining every single step in detail. But yeah, these are long, difficult problems. Plenty of opportunities to make mistakes. Which is why I prepared plenty of examples. We'll skip over this one. I showed you this one already yesterday. Let's do chlorine and nitrate in acid. So in an acid solution, chlorine and nitrate. We're making chlorite and nitrogen. If you're following along at home, go ahead and pause here to try and do it on your own. For those of us watching live, let's go ahead and just dive right in. All right, so first up, oxidation numbers. As per usual, I will now go a little bit faster with this to try and keep this from being a 2-hour video. So, chlorine is going from 0 to +1. Chlorine is being oxidized. Nitrogen is going from +5 down to 0. Nitrogen is being reduced. So now we can do our half reactions. Reduction half reaction, our oxidation half reaction. Don't forget to leave lots and lots of room when you're writing these out, because you will need it. First step, balance everything but hydrogen and oxygen. So, 1 nitrogen on the left, 2 nitrogens on the right. We need a 2 there. 2 chlorines on the left, 1 chlorine on the right. We need a 2 here. Now we balance we balance oxygen by adding water. This is a place where people commonly make a mistake. We have a coefficient and a subscript. Don't forget to do that necessary multiplication. We have 6 oxygens on the left, 0 oxygens on the right, so we need 6 water to balance that out. 0 oxygen on the left, 2 oxygen on the right, we need 2 water down here. That is a very common mistake. I make it myself a lot. There's plenty of opportunities to drop things, forget things. That's why I emphasize the need to double check there at the end. All right, now we balance our hydrogens. Balance hydrogen by adding acid. So we have 12 hydrogen on the right versus 0 on the left. We're going to need 12 H+. 4 on the left, 0 on the right. We need 4 H+ down here on the bottom. And finally, we balance out our charges. So, positive 10 on the left versus 0 on the right. And then 0 on the left versus positive 2 on the right. We need 2 electrons down here. Okay, so now we've balanced each half reaction in itself. We need to balance the electrons so they disappear. This is where being able to balance or do whatchamithings, least common multiples, will help you out. You could multiply the top half by 2, the bottom half by 10, but the fact is that 10 is a multiple of 2. all you really need to do is multiply the bottom reaction by 5. Okay, that's what I mean by least common multiples. All right, so 5, 10, 10, 20, and 10. So when you add these together, your electrons will cancel. Damn it. That ain't good enough. And so will some other things. All right, so 10 electrons cancels out, as it should. Now we have 20 hydrogens down here. We have 12 hydrogens up here. So 20 minus 12 will leave us with 8 and 0. Then we have 10 water versus 6 water. The 6 water cancels. 10 minus 6 is 4. So now we just add together everything that remains. All right. That might be the balanced reaction. Again, there's no way to really know for sure until you double check. So, nitrogen, chlorine, hydrogen, oxygen, charge, and coefficients. Two times 1 means 2 nitrogen on the left. 1 times 2 means 2 nitrogen on the right. Five times 2 means 10 chlorine on the left. 10 times 1 means 10 chlorine on the right. Hydrogen only shows up in water. Okay, so 4 times 2 is 8. 8 times 1 is 8. Oxygen. 2 times 3 is 6. 4 times 1 is 4. 6 plus 4 is 10. On the right, it's only in the hypochlorite. So 10 times 1 is 10 oxygens. All right, so all of our atoms balance out. Charge. Water and chlorine are neutral, so it's -2 on the left. Nitrogen is neutral. Let's see, we have 10 hypochlorites and 8 hydrogens. So that's going to also be -2 on the right. Huzzah. So charge balances. Now coefficients, 2, 5, 4, 10, 1, 8. There is no common denominator. I can't divide through by anything. So the coefficients are right as well. So now that reaction has been balanced. And just to do one last bit of double checking, yes, I was looking to balance that out in acid. So we don't need to get rid of the H+. Don't need to get rid of the H+ by adding OH-. So that is that reaction nicely balanced. So here's this one. Magnesium chloride plus lithium metal reacting to produce magnesium plus lithium chloride, and this is happening in acid. Okay, so magnesium chloride plus lithium, magnesium plus lithium chloride. All right. The half reaction method is actually overkill for this one, but decent enough practice. Screw it. It's just overkill. We don't really need to do anything for this one except we can balance this one just like anything else. All right. So yeah, the half reaction method isn't always necessary. Okay, for something really, really simple like this, you don't need to go that far. It's when you have more complicated redox reactions that you're really going to need this. When you see random charges, when you see random hydrogen and oxygen, get you the half reaction method. Otherwise, it's just overkill and unnecessary. Like, for example, this one. As it's written, there is no possible way to balance that reaction. Lead plus arsenate makes lead 4 oxide plus arsenic 3 oxide. It's just not possible. And you know that because you have the 3 minus charge here. There's no charges on the right. There's no way to properly balance that unless you use the half reaction method. So let's get to it. Okay, so just dashing through our reduction and oxidations. Lead is being oxidized from 0 to positive 4. Arsenic is being reduced from positive 5 down to positive 3. So now we split it into our half reactions. Ugh. Killing me, Smalls. All right, so now we balance everything except hydrogen and oxygen. So we have 1 arsenic on the left, 2 arsenics on the right. So we need a 2 there. 1 lead on the left, 1 lead on the right. We don't need to do anything to that. Now we need oxygen. Don't forget, coefficients matter. So 2 times 4 gives us 8 oxygen up top left. 1 times 3 is 3. So 8 versus 3, we need 5 water over here. And we need 2 water down there. Now we balance hydrogen by adding H+. 0 versus 10, we need 10 hydrogens here. 4 versus 0, we need 4 down there. And now we need to balance charge. So 2 times 3, 6 minus. 10 times 1 is 10 plus. Four plus versus a total of 0 means we need 4 electrons right there. Coming down here to oxidation, it is neutral on the left. And here for H+, on the right, it is a total of 4 plus. So we need 4 electrons down here as well. And Frabjous Day, we don't need to balance the 2 half reactions against each other. 4 electrons up top, 4 electrons down bottom. We don't need to do anything. We are going to be able to take these 2 reactions and just add them together. Easy peasy, lemon squeezy. So we grab this, we bring it up. So our electrons cancel as always. Hydrogens, we have 10 versus 4. 10 minus 4 will leave us with 6. Water, 5 versus 2. 5 minus 2 is 3. Okay. And if this were an acid, we would be able to stop, but this one is in base. So we're going to need to do step 6, where we get rid of the acid, where we add OH minus. So let's go ahead and do that. 6H plus means we need to add 6 OH minus. Remember, when you add hydroxide, you're adding it to both sides. H plus OH minus makes H2O. And then 6 versus 3, H2O cancels, leaving us with 3 H2O on the left. And now our fully balanced reaction is going to be that. 2ASO43 minus plus Pb plus 3H2O yields As2O3 plus PbO2 plus 6OH minus. Which means, once again, we get to double check. Check all the elements, check the charge, check the coefficients. We have 2 arsenic on the left, we have 2 arsenic on the right. 1 lead on the left, 1 lead on the right. Hydrogen, 3 times 2 is 6, 6 times 1 is 6. Oxygen, 2 times 4 is 8, 3 times 1 is 3, 8 plus 3 is 11. 3, 2, 6, 11. Haha. And charge. 2 times negative 3 is negative 6 on the left. Negative 1 times 6 is negative 6 on the right. And as for coefficients, 213, 116. No common denominator. All right. So that is another balanced redox reaction. I wish I could say it was always that easy. Redox reactions are difficult to balance. This is a long, complicated process. It is difficult. It is annoying. It is enough to make you cry. That is perfectly normal. That is perfectly natural. Chemistry often does that to people. And just go ahead and accept that that's the way it's going to be. Okay. We have more reactions here, but we'll leave that as an exercise for you to do at home. It has been a long day. I'm sure you are feeling somewhat brain fried. Practice these. Practice, practice, practice. This will be on the test. Absolutely. No two ways about it. I don't know how they'll do it for an online test, but they will. It's going to be a thing. And with that, we are done for today. I will see you in the future. I'll stick around for about 30 seconds for any questions from the chat.